Greetings, this is Bob Thompson with Salt Lake County. I'm here to present the April 4th, 2023 Snowpack update on behalf of Flood Control Engineering and Watershed Planning and Restoration. The water year, which begins on October 1st, has been an incredible water year. We've had all kinds of atmospheric river events happening, which tend to flow across the western United States and have deposited an immense amount of precipitation all the way from California through Nevada and into Utah. That makes the Drought Monitor look way better than it has in the last few years. As you can see, the western United States is mostly in drought, but this picture has dramatically increased over the past 12 months. And Utah in general, you can see that the eastern portion of the state is largely out of drought, and there's a small swath on the western portion of the state. Central Utah is still mired in severe drought. Looking at the seasonal forecast for drought, there's a significant portion of the state that may be removed from drought status, whereas central Utah is likely to remain in drought, and the drought definitely persists in southern Utah. The reason why that's happened, our snowpack has been immense. Most of these basins in northern Utah are showing 200% plus what normal snowpack means. And the way that is measured is in what's called snow water equivalent. And that's how much water is contained in the snowpack. To zoom in on northern Utah, these are the basins that make up northern Utah, and the Salt Lake Valley is located right here. Now, all of these dots are individual stations that monitor snow water equivalent. They're called SNOWTEL stations. So the first slide I'm going to show is an aggregate of the SNOWTEL stations that make up the Lower Jordan Basin, or basically the basin of Salt Lake County. So I've added a few different water years on this slide. Again, the water year begins on October 1st and water accumulates throughout the year. And I've got a bunch of lines on here to show what this line indicates an average water year accumulation. The next line up, this green line, this is 2017's water year. And as you can see, in 2017, we had a really immense amount of snow come early March. And then we had a warm spell in early March, which melted a significant amount of that snow. And then we accumulated a little bit more. And then we melted a little bit of that snow in mid to late April. Now, a lot of folks are worried right now about the warm spell that's forecast for the end of this week and early next. And really what that's going to look like as far as the melt of our snowpack goes is, yes, we are going to see some of this snowpack, especially the low elevation and south facing snow, start to melt. And then even if we have another storm forecast, and right now there is one forecast for tax day, that snow may begin to again accumulate, but then it'll usually taper off and melt. And this is usually kind of the step down or the best case scenario for flood control. In 2019, we had a similar accumulation, but instead of starting to melt in early March, in 2019, we accumulated almost until May, and then we had a significant melt off, truncated by a small storm event, which created a little accumulation, and then another warming event, which melted a lot of snow, truncated by another cool snowpack or snow accumulation event, and then we finished our melt all the way through June. Now, these little storms, even if they accumulate a little bit of snow, are actually wonderful for slowing down runoff, and this step-down approach to runoff from a flood control perspective is the best possible scenario. 2011 is our max recent water year, and you can see snow accumulated all the way until May, but then again stepped down with a few storms truncating the runoff event. So in 2023, the best case scenario that we can hope for is an immediate warming trend. And the great thing about having a warming trend in April is that the sun really isn't high enough in the sky to start working on north-facing slopes. So the snow that will melt first with this warming trend is likely going to be the lower elevation and south-facing snow. And although that may raise creek levels significantly, it's ideal to have creek levels rise over a longer period of time than it is to have this 2023 accumulation curve continue on the up and up trend and then all of a sudden melt in June and July. That is the worst case scenario for flood control. So looking at individual stations, starting at low elevation on the north end of the valley, this is Lewis Meadow in City Creek Canyon. As you can see, 2023, our accumulation is significantly above historic max values. So again, we want to see this get as warm as possible, as soon as possible, so we can start melting the lower elevation and south-facing snowpack, because the more differential the melt becomes, the longer duration that creeks will stay high and the less likelihood of flooding. And I know that can be counterintuitive, but we really do want it to get warm soon. Moving higher up in elevation, this is Lookout Peak at the top of City Creek. Again, 2023 snow accumulation is significantly above what we've seen in the past. The average peak date for City Creek at the upper elevations is getting close to May. So we're getting to that point here now that we're in April. We want to see this 2023 accumulation start to taper off, and we'd love to see that start to melt. And we'd also love to see some storms truncate that melt from time to time. Moving further south, this is the Snowtail site at Parley Summit. Now, Parley Summit has a long period of record, and I can show some historic significant years. So 2011, that's a recent historic significant year, but 1984, there's a lot of folks my age who remember that year, and 1984 was a very significant snow accumulation year. The snow really peaked right around mid-April, and then it started to melt off, and then it started to accumulate, and then once we hit mid-May, it just raced off the slopes. And this is the scenario we'd like to avoid. We don't want to see that whole snowpack go through one melt cycle. We'd at least like to see some of these truncated melt events through storms like we did in 2011. But Mother Nature gets to make the final call on that one. Moving further south, this is Mildy North, which is actually a south-facing slope in Big Cottonwood Canyon. And you can see on the south-facing slopes in Big Cottonwood Canyon, we have a lot more snow than we historically have ever seen. So 2023 is a banner year for that. Up at Brighton, 2023, same story. It's a banner year. We've got more snow than we've ever seen. We would love to start seeing that get melted again through these truncated accumulation and melt events. That would be an ideal scenario. Snowbird in Little Cottonwood Canyon has, again, historic max values. And since this is on a north-facing slope, even if it does warm up, we actually would not expect to see this black line start to truncate. It may plateau for a bit, but the sun really isn't high enough to start working on those north-facing slopes. And not to go too far into snowmelt physics, but it really does require direct solar radiation to create an efficient melt cycle. Just temperature won't really do it as well all by itself. So we're not expecting these north-facing slopes to start melting yet. So what do we have in the forecast? Well, 7-day precipitation forecast looks like we have the end of that storm that just finished up. And after that, we're hoping it'll dry out. That's what the forecast is indicating at the moment. Monthly precipitation for the month of April says we may actually be slightly above. We might be leaning above average for precipitation. Seasonal precipitation means we're looking at normal conditions. But as a reminder, April, May, and June for this part of the West tend to be fairly wet. This Salt Lake Basin, we tend to have a lot of storms this time of year, so it doesn't mean we're going to be dry. Temperature outlook for, again, the Salt Lake Valley looks like we're going to be below average for the month of April. Seasonal temperature outlook for April, May, and June is also forecast to possibly be slightly below average. So when we look at what our streamflow forecasts are, they are significantly above average. So for north of us, we're looking at 150%, west of us, 178, south of us, we're looking at 163. So all of these are well above average. So where does all that water go? Well, we've got a few reservoirs and lakes that have significant storage capacity. Right now, Utah Lake, as far as percent full goes, it's hovering between 50 and 60%. So recent values indicate just below 58% full. It takes a lot of water to fill up the remainder of Utah Lake. So with 58% full, we're roughly 4 feet compromised. And to fill up the top 4 feet of Utah Lake, it can really take a lot of water. Other reservoirs of note, we've got many reservoirs that serve our water suppliers for the Salt Lake Valley, like Jordanelle at 60% full. 50 to 60% is kind of what we're looking at for a lot of these reservoirs. So there is some storage capacity to put that water in some of these reservoirs. Probably is not as much as we'd like for future use, but at least we have some space, and water managers are making great decisions trying to create more space as we're looking at what exists in the snowpack still. So there's a lot of information that's been presented here. Just to highlight some of our data sources and partners: the Central Utah Water Conservancy District, NOAA, NRCS, US Drought Monitor, Utah Division of Water Resources, and the Western Regional Climate Center. They've all been wonderful in providing timely and as accurate as can be forecasts. And if you have any remaining questions, you can reach Salt Lake County Flood Control at 385-468-6600. And we've got a great preparation page for anything relating to flooding, preparations, stuff like that. You can reach it at this URL here, slco.to/flood prep. Thanks for your time.